In your lesson yesterday, you learned how to add unlike fractions, which are fractions that have a different number in the denominator. You learned to do that using models, area models like this. Today, we're going to do the same thing, except when you add these two numbers, you are actually going to get an answer that is greater than 1. Okay, so it's going to be the exact same thing, it's just going to look a little bit different. Let's get started. So the first thing that we need to do is we need to go ahead and we need to split this rectangle into 3 pieces because 3 is in the denominator. And remember that we always use vertical lines on one and then horizontal lines on the other one. And then I need to shade in 2 of those. So I'm going to go ahead. I should have used a different color, but I didn't. So there we go. Okay, so I shaded in 2 of those 3 pieces. And I'm going to do the same thing here, except I'm going to do vertical lines or horizontal lines, sorry, this time. So there are 3, or there's 4 pieces. I need to shade in 3 of them. So I'm going to go ahead and I'm going to shade in 1, 2, 3, just like that. Okay. And then I can go ahead and I can turn these into equivalent fractions. So you can remember that what we do, oh, you know what? Ooh, I forgot I can do this. I'll go ahead and take this. I'm gonna copy, and then down here, paste so that it's easier. Okay, so I have those, and then I can go ahead and I can add in those other lines. So here I'm going to go ahead and add in those 4 lines like that, and then down here I'm going to go ahead and add in the 3 lines like that. So now I can figure out what my new denominator is. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 in the denominator, which means I'm also going to have 12 down here. And shaded, I have 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 shaded pieces. And here I have 1, 2, 3, 4, 5, 6, 7, 8, 9 shaded pieces. So I have 8/12 plus 9/12. Those are my equivalent fractions. You can see that 8/12 is the exact same thing as 2/3, and you can see that 9/12 is the exact same thing as 3/4. It just looks different because we've cut them into a bunch of pieces. Okay, so now that I have my equivalent fractions, I can go ahead and add those up. So I can do, let's see, I'm going to go ahead and draw my boxes again. I'm going to draw one box, and I'm going to cut it into 12 pieces because I know I have 12ths. Okay. And then I'm going to start counting up those shaded boxes and shading them down here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I have 17 twelfths total. And I'm going to go ahead and shade those in. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and you can see that I ran out of boxes before I got to, or the little sections before I got to 17. When that happens, if you're drawing a model, what you have to do is you have to add another box for 12ths again. So there are my 12ths. And then I can go in and I can add the rest of those boxes that I wasn't able to fill in here. So I had 12 here, I needed 17, so 12, then 13, 14, 15, 16, 17. Okay, so there is my model of 17/12, which is my answer. But there is another way that we could name this. Instead of saying 17/12, which there's nothing wrong with that, but you can also see that I have one full shaded box. So I have one whole box. And then over here I have 1, 2, 3, 4, 5 of those little 12th pieces left over. So I have 17/12, but I also have one full box and 5 little 12 pieces left over. So I have 17/12 and I have 1 and 5/12. Okay, let's do one more and then I'll let you go off to your lesson. This time, let's do 1/3 plus 4/6. 1/3 plus 4/6. Okay, so I'm going to draw my rectangles. And I'm going to go ahead and shade in or turn them into fractions. So here's my 1/3. That means I have 3 pieces and I am shading one of them. And then down here I have 4/6, which means that I have 6 pieces. And remember that you always have to do one of your models with vertical lines and one of your models with horizontal lines. Okay, so there's my 6, and I need to shade in 4 of them. So here's 1, 2, 3, 4. Okay, so there is 1/3, and there's 4/6, and I'm going to go ahead and turn those into equivalent fractions. So I'm going to take my pen and I'm going to add those 6 lines, those horizontal lines here. There's 6 of them. And then down here, I'm going to add my third lines. Oops, almost messed it up. Gotta do thirds. Okay, so now I need to figure out what my new fractions are. So here I have, or my new denominator, equivalent fractions, however you want to say it. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I've got 18 little squares in all. That means the bottom number is going to be 18. And how many are shaded? 1, 2, 3, 4, 5, 6. I have 6 of those 18 pieces shaded. Here I'm still going to have 18. And how many are shaded? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 are shaded. So now I have like fractions, which means the denominator is the same, which means that I can add them up. So on this one, I am going to have 12 plus 6. 12 plus 6 is 18. So I have 18 18ths. I could check that by counting. So there were 12, 13, 14, 15, 16, 17, 18. So in this one, when we draw our model to show those, I'm going to go ahead and do my third lines down. I'm going to show the answer. Then there is my 18ths. I'm going to go ahead and shade in 12 first. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I'm going to add on those 6 right here. 1, 2, 3, 4, 5, 6. So you can see here that I didn't run out of room. We can name this 18 18ths. There's nothing wrong with that. But we can also see that we have one full rectangle shaded in, which means that 18 18ths is the exact same thing as one whole. Just like that.